All right, ready for this. Today, we're diving deep into something pretty crazy. A galaxy that's actually moving towards us. We're talking about Messier 90, or M90 for short. And we've got some new info hot off the press thanks to the Hubble telescope.
You know, what's really wild about M90 is that it's going against the flow, so to speak. Like the universe is always expanding, right? Pushing most galaxies away from each other. But M90,
Yeah.
it's like bucking the trend. It's on a path to, well, basically collide with our little corner of space.
Talk about shaking things up. Now, I know it's part of the Virgo cluster, but how far away are we talking exactly?
Let me put it this way. Imagine we had a spaceship and it could travel at the speed of light, the fastest speed possible. It would still take us a mind-blowing 55 million years to reach M90. That's how far away it is.
Whoa, okay. I'm starting to get a sense of the scale here. So what's this new Hubble data telling us about this galactic rebel?
Well, Hubble has actually snapped pics of M90 before, but this time it's using its Wide Field Camera 3, which they installed back in 2009. This camera gives us like a much wider view of the galaxy, showing us all these little details we couldn't see before. It's like going from blurry binoculars to an HD telescope.
I am always down for a cosmic upgrade. What kind of details are we talking about specifically?
So this new image, it shows M90 in all its glory. You know, you can see that dusty disk swirling around, the huge halo of gas surrounding it, and its bright core, where there's probably a supermassive black hole lurking. It's really something else.
Oh, I bet. And speaking of eye-catching things, I heard there's a certain color in this image that's got astronomers talking. Something about red light and star formation.
You're right on the money. The inner parts of M90's disk, they're glowing with this specific red light. It's called H-alpha. Think of it like those neon signs you see. They're filled with these, energized gases. And in space, that same kind of glow means new stars are being born.
So those red bits in the picture, those are like cosmic nurseries where stars are popping up. That's so cool.
Yeah.
But I also read that M90 has had kind of a tough time in the past.
Yeah.
Something about a cosmic headwind.
Yeah, the hazards of galactic travel, traveling through the Virgo cluster, it's like a crowded highway for M90. You ever driven through really thick fog? It creates all that resistance, and it can slow you down. That's kind of what's happening to M90, but instead of fog, it's intense gravity and a ton of gas it's running into. About 300 million years ago, this headwind basically stripped away a bunch of its gas, leaving this wispy halo around the galaxy.
Hold on, so a galaxy can lose its gas. That's like a car running out of fuel, isn't it?
You got it. And gas is like super important for a galaxy. It's what they use to make new stars. Without enough gas, star formation just stops. It's kind of like a cosmic retirement party. The existing stars are still shining bright, but there are no new stars joining the fun.
That makes you wonder. If M90 is losing gas and its star-making days are slowing down, what does that mean for its future? Will it just fade away?
That's a really good question, and it leads us to one of the most amazing parts of M90's story, its transformation into a lenticular galaxy.
A lenticular galaxy, so is it shaped like a lentil or something?
Not exactly, but it's a good way to remember the name, I guess. Imagine a frisbee, but someone spun it so fast it started to flatten out. That's sort of what a lenticular galaxy looks like. It's a flattened disk, but without those, beautiful spiral arms we see in galaxies like our own Milky Way.
So M90 is going through a cosmic makeover, trading in its spirals for a more streamlined look.
You got it. And this whole transformation is happening because it's losing gas. As M90 keeps moving through space and losing more and more gas, its spiral shape is going to fade away slowly. Think of it like a dancer spinning and slowly extending their arms until their body forms one smooth line.
Okay, I can see that. But here's what I don't get. If M90 is losing gas and changing shape, it must be going through a pretty crazy ride, right?
Oh, absolutely. And that leads us to another incredible thing about M90, how incredibly fast it's moving. Not only is it going against the expansion of the universe by coming towards us, but it's also zooming through the Virgo cluster. And this speed is actually the key to understanding why it's on a collision course with us.
Now you've got me on the edge of my seat. Tell me more about M90's need for speed.
Well, to understand that, we need to talk a bit more about galaxy clusters and how their gravity can create, well, a kind of cosmic demolition derby.
Bring it on. I'm ready to unravel this gravitational puzzle.
So picture this, a big city with cars going everywhere. Each car is like a galaxy in a cluster, and their movements, all influenced by the gravity of the other cars, the other galaxies around them.
Okay, I'm seeing it. It's like a cosmic traffic jam. Each galaxy pulled this way and that by its neighbors.
Exactly. Now, most of the time, the universe expanding acts like a strong wind, pushing those cars apart, spreading the city out, so to speak. That's why most galaxies are moving away from us.
So it's like a cosmic breeze, gently pushing everything further apart. But what about inside the cluster? Do galaxies there ignore this wind?
That's where things get interesting. Within the cluster itself, gravity's way stronger than the expansion. Imagine those cars, bumper to bumper. Their pull on each other outweighs any wind.
So they're locked in this gravitational dance, constantly pulling at each other. But how does that explain M90 going so fast and towards us?
Think of it like one of those cars getting bumped hard by a bigger vehicle. It could send it flying off in a new direction, even against traffic.
M90 got a cosmic fender bender. That's one way to escape a traffic jam.
Exactly. Astronomers think M90's been interacting with other galaxies in Virgo, especially those near the center, where it's crowded. These close encounters, those bumps, have sped it up and changed its direction, sending it towards our local group.
Wow, so it's like M90 got a one-way ticket at a Virgo, and our local group is the destination. That's both amazing and a bit intimidating. Do we know what'll happen when it gets closer?
Well, we can't predict the future perfectly, but we can look at its path and how gravity works in our local group and think about possibilities. One is that M90 gets pulled in, becomes gravitationally bound, and ends up orbiting our Milky Way, or Andromeda, its big neighbor.
So M90 could become our new cosmic neighbor. What would that look like from Earth?
If that happened, M90 would get much brighter in our sky. Imagine looking up, not at a faint smudge, but a bright, swirling disk of stars, maybe even visible without a telescope.
Now that would be a sight. But are there other options besides M90 settling down?
Oh, definitely. It's also possible M90 just passes through our local group. It might hang out, interact with our Milky Way and others for a bit, then keep going.
Like a cosmic tourist, stopping by before heading off to explore more of the universe.
Exactly. But even a short visit can have big effects. Gravity can trigger new stars forming, distort galaxy shapes, even cause them to merge. It's a dance where partners change and evolve with each encounter.
This is incredible. It shows how dynamic the universe is, how even galaxies far apart can influence each other and shape everything.
That's it. And M90's journey is a perfect example. It shows how powerful gravity is, how galaxies are linked, and how the universe never sits still.
It's not just one galaxy on the move, it's a whole story about the forces and connections that govern the cosmos.
You got it. It reminds us that even across vast space, we're connected, part of this cosmic dance that's been going on for billions of years.
It really makes you think, will M90 stick around or wander off? I guess only time will tell.
Exactly. But for now, we can appreciate its beauty, study it, and let it remind us of the vastness and wonder of where we live.
Speaking of beauty, let's get back to M90 becoming lenticular. We touched on it earlier, but I want to dig deeper into what that means for its appearance and its future.
Of course. It's a fascinating transition that shows how galaxies change over time.
I'm ready to learn more about the next chapter in M90's story. Okay, so back to M90 transforming from this beautiful spiral to a lenticular galaxy. What does that actually look like for M90? Will it still be, as stunning?
It's funny, that's a question that comes up a lot. And while, yeah, the change is big, it doesn't make M90 any less, captivating.
Okay.
Think of it like this. A spiral galaxy with all those arms swirling bursts of star formation. It's like a young dancer, full of energy, all those dynamic moves.
Oh, I like that. I'm picturing like a sparkly costume too.
Right. And then a lenticular galaxy, it's smoother, more settled. It's like that dancer later on. Maybe their style is more about grace, elegance.
So less about like flashy steps and more about controlled, beautiful lines.
Exactly. So as M90 loses more gas, those spiral arms fade. It'll become smoother, more lens-shaped, but it's not like it's becoming dull or anything.
It's not a fading star, just a different kind of star.
You got it. Lenticular galaxies, they can be super bright. Often they've got this concentrated glow from their central bulge. Might not have that youthful energy of a spiral, but they've got their own kind of, mature beauty.
So even though M90 might be slowing down in terms of new stars, it's not going to just disappear. It'll still shine out there.
Oh, absolutely. And that brightness is actually really helpful for astronomers. We can see them from much further away, which gives us more data to understand how galaxies evolve.
It's pretty amazing. Even as it changes, M90 is still teaching us things, still fascinating us here on Earth.
That's the universe for you. Always got something to teach us.
Well, as we wrap up our deep dive into M90, I've got to say, what a ride. We covered its spiral arms, the gas it lost, its crazy trip through Virgo, and then becoming lenticular. Talk about change, resilience, and just cosmic beauty.
And it really highlights that everything's connected out there, from the tiniest particles to these huge galaxies. We're all part of this, well, cosmic dance, shaped by the same
It
forces.
makes you feel small, but in a good way.
Absolutely. And next time you look at the night sky, remember, every little point of light is a whole galaxy, each with its own story, just like M90. Who knows, maybe there's another one out there heading towards us right now, ready to share its secrets with whoever's around to see it.
I love that thought. And to all our listeners, keep exploring, keep learning, and never stop wondering about what's out there.
Till next time, keep looking up and stay curious.